Good morning, everybody. This is Carl Griffith from Graybar, and I would like to welcome you to our first G2 Talk webinar of 2014. Hope everybody had a good respite at the end of the year, and we're ready to get going for 2014. Following the Graybar PowerSmart theme, our G2 Talk webinars will be about energy, and they'll be about intelligence and how those two things converge inside buildings and facilities, and that's exactly what we're going to talk about today when our building our facilities a data center. So today we're going to have a conversation about cooling in the data center, and we're looking forward to that. Before we get started, I want to remind you all of a few things. Number one is that if you're one of the first 50 people that are online watching this webinar, you'll get an email later today for a free cup of coffee from a large major coffee chain in the United States. That's our gift to you, and we're just glad to offer it to you, and thank you very much for being with us online today. The second thing I wanted to remind everybody is that this presentation will be archived. It will be on graybar.com. If you'll go to graybar.com and click on the G2 Talk logo, it'll direct you to the archive, and then you can look at this presentation again, share it with your colleagues, download a white paper, whatever might be available to you there on the archive. The third thing I wanted to mention is that there's an opportunity for you to ask questions during this webinar. So at the bottom of your screen, you'll see a little button there that says Q&A. If you open that, it'll open a chat box, and you can type your question in that chat box. And then at the end of the presentation, we will go over those questions, and if we don't get to all of them, we will answer them remotely. But put your questions in there, and at the end of the presentation, we'll go over them. So be sure to do that. All right, our presenter today is Joe Capes, and Joe is the Business Development Director for Schneider Electric's cooling line of business. Joe's been in the industry for many years. He's responsible for that business development for cooling for Schneider. And you may have run across Joe from time to time. He appears at industry events. He's been at AFCOM and Data Center Dynamics. He's been to 724. He's also spent some time with the Gartner folks at their data center summits. And we're just extremely fortunate to have Joe as our industry expert today to talk to us about the three big cooling solutions and the trends that we have inside data centers. So without delaying this any longer, I'm going to pass the baton over to Joe. Thank you, Joe, for being with us on G2 Talk today.
Well, Carl, I really appreciate the kind introduction, and I'm very, very excited to have this opportunity to speak to the audience today. I see we have a lot of people on the line, and it's great to see such a high turnout. I want to thank Graybar again for this opportunity. So today we're going to spend some time talking about cooling in the data center, and I think this is a very timely discussion and presentation really to have based on some of the dramatic and very fluid changes that we're seeing in the industry today. So as we kind of get into the flow of the presentation, I just want to cover the agenda very quickly with you. And really what I want to do is kind of summarize for you what are the top three trends that Schneider Electric's seeing in our industry today in North America, one of which is pointing us strongly in the direction of economizers. And we'll talk about economizers to give you some background. If you have not used economizers in your facility, or maybe if you have, I think we can give you some nice takeaways here. I also want to talk a little bit about what I refer to as high-performance cooling. We talk about HPC, we talk about high-performance computing a lot, but these applications are heavily dependent on the ability to cool very, very high density of IT and storage equipment. So we'll talk about what's happening there. And then I also want to give you some maybe some little bits of experience that I've gained over the years and look at our own portfolio of cooling solutions to give you an idea of where do you start when you have a new data center build or you have an expansion to your facility, and it can be really challenging to figure out where to start and maybe what the right cooling solution is for you. So without further ado, let me just go ahead and jump into that. And let's talk a little bit first about what's happening with data centers as a whole today. If you look at the industry, I think bar none, the biggest change that we're seeing, not I'm seeing, is this massive movement towards outsourcing with cloud and colo. If you look at various industry estimates, we're really looking at about a 2.5 or even more, even higher increase in deployments to cloud and colo through the end of this decade. And what that means is not only will more and more of you outsource your IT equipment, your IT applications, and the infrastructure that supports all that gear, but also the type of cooling and the requirement set for the cloud and colocation facility is very different than a traditional data center. So that's a big takeaway and a big driver for a lot of what we're seeing happening and how data center cooling equipment is changing. We still have some pretty robust, strong growth in the enterprise segment and HPC. So when we talk about high-performance computing, we still see HPC applications embedded in all types of data centers, whether it be cloud, colo, or enterprise. And then we see purpose-built data centers, certainly in government institutions, laboratories, in higher education, and certainly in banking and finance for really high-density compute, number-crunching applications, and that requires a whole different solution set. But I think, again, the major thing to look at in the industry as a whole is this massive migration to cloud and colo and outsourcing, and we'll talk about how that's really changing the dynamics. Now, why is cooling important? For some, cooling is sort of the plumbing, the mundane part of a data center and how you operate it. But from the standpoint of importance, it's right up there at the top, if not at the top. If you look at this particular slide, what it really says is that the cooling infrastructure, both the indoor units and the outside heat rejection, can represent, on average, about 50% or half of the total energy that's consumed by the facility. And that includes the IT power that's consumed by the facility. In this case, it's a good example and a good highlight to consider that the outside heat rejection, the chiller plants, the air-cooled condensers and so forth, those are actually a huge, huge energy hog for the data center. So it's important as we start to talk about economizers to reflect on the fact that when you look at cooling efficiency, we're not just talking about the indoor cooling units, the cracks, the crays, the in-row units, but we're also talking about the outside heat rejection. So when we look at market trends, I'll try and break it down into these three trends that I mentioned at the top of the agenda. The first is we're seeing this massive movement and migration to using economizers. I'm going to talk a lot about economizers and really what that means, but the biggest effect on using economization is driving higher efficiency, lowering your power use, and also lowering your energy bill. One of the biggest drivers for this has been the widening of the supply air temperatures and also the humidity conditions driven by ASHRAE TC 9.9 committee and other segments and guidelines that have been published by ASHRAE, a very prominent cooling and heating industry association that many of you, I'm sure, are even members of. Now, AHRI is another subset of this whole area of standards and regulations where the various manufacturers of this equipment now will be testing their equipment to AHRI standards. And what that does and how that benefits you is that each manufacturer that tests to AHRI standards will test to the same exact conditions and criteria so that when you're comparing cooling solutions, you're getting a fair apples-to-apples ability to really compare the solutions based on performance and efficiency and so forth. So this is a great beneficial aspect of where the industry is moving. And not to be outdone, the U.S. Department of Energy has a play now where they actually have published specific mandates and guidelines for the use of economizers in data center facilities. So whereas in the past this was really dictated solely by the local jurisdiction involved, whether it be local, state, really now we're seeing the Department of Energy dictate and mandate these energy efficiency standards. Consolidation we talked a little bit about already, and the fact that we're seeing more and more outsourcing of IT compute, storage, and applications to these cloud and colo facilities. And the interesting thing about, for instance, the cloud type of data center is we find that the cloud data center is a little bit less focused on redundancy, but much more focused and highly focused, I'll say, on efficiency, because the scale of these data centers is so huge and so magnified that small mistakes that are made in the selection of cooling equipment, for instance, are of a magnitude that can cost millions and millions of dollars of energy on an annual basis. So the decisions made in the cooling infrastructure and how to really make the overall data center operate efficiently are paramount. Another area that's really interesting is fluorocarbons. And countries like Japan, Denmark, Germany have traditionally been leaders in this area. And over the past decade or so, we've basically eliminated refrigerants like R22. We've migrated to refrigerants like R410A, R134. But now we're actually seeing other refrigerants come into play with new mandates for eliminating, reducing fluorocarbons and greenhouse gases. When these refrigerant changes occur in the industry, it actually presents a challenge and a wrinkle to manufacturers like Schneider Electric, where we have to be able to address the actual design and architecture of the cooling solution to work with these refrigerants, and oftentimes at the expense of capacity or performance. So we're going to be keeping a keen eye on what's happening globally with fluorocarbons. And then lastly is a migration, evolution we've all seen towards modular prefabricated data centers. And this is an area that is really starting to pick up within North America. We're seeing more and more data centers going to modular, pre-tested, pre-engineered solutions. And that really provides the benefit of much faster deployment and construction of the data center facility in terms of months versus years. So these are all really key market trends, the three top ones being economizers, migration to cloud and colo, and then this global market trend towards changing refrigerants and changing formats in the data center. So when you look at, hey, how does this apply to me? If I haven't been using economizers in my facility thus far, what does that mean? Well, if you look at this slide, this is a simplified version of the ASHRAE 90.1 climate zone, which actually shows which geographies will have mandates and do have mandates in place for the use of economizers. So if you're operating an existing data center and you're going to be making an expansion of that facility, or if you're in the interest of building a new facility, any of the areas shown here in blue have specific regulatory mandates in place for the use of economizers in cooling systems that exceed those capacities shown down in the lower left-hand corner. So again, an important thing to remember here is that if you have data center facilities in any of these geographies, there are mandates in place, and these are real. These are already here, and you need to be investigating what's required at the local level to meet these energy efficiency standards. So when we talk about economizers and what is really encapsulated by this change, in the past, economizers were really used as a supplemental mode of operation. So you might be using a standard air-cooled DX unit and then have some type of economizer function in your facility that would allow you to get better efficiency during certain times and certain hours of the year, whereas now the use of economizers is becoming a primary mode with mechanical refrigeration-based systems as backup. And so I think that, and this slide really tells you that for new data center builds and expansions, economizers are becoming a fundamental component of the design criteria for the cooling system. So let's talk about economizers and what some of these different modes of operation are. And I think when we look at an economizer, I want to make sure you understand that this is not a thing, it's not an object, it's really a mode of operation. And it's a way for the cooling system to save energy by using less power. So you have systems out there today that have been substantially improved over the last 10 years, whether it be traditional computer room air conditioning systems that are mounted up against the wall, or whether it be in-row cooling units or overhead cooling systems. A majority of the manufacturers, and certainly including Schneider Electric, have done a lot to improve the efficiency of these systems. But to make that next quantum leap and that next quantum step, the important thing is to try to bypass the use of the compressor, the mechanical component of the cooling unit, through the development of these various economizer modes that I'll talk about here now. When we do talk about economizers, the geography is very important, and I already referenced that in the slide previous to all the blue areas shown in the United States. But certainly the ambient conditions in the geographical location are paramount to what level of economization you can actually use and benefit from. Also the cooling set points. In the past, I think we've all been in facilities that are like refrigerated meat lockers. We've seen data center set points back in the mid-60s, and I'm talking Fahrenheit temperature there, not a time period. Nowadays, we're seeing most engineers designing facilities to 75-degree Fahrenheit set points for supply air to the inlet of the server. We're seeing more facilities that are really pushing up towards the ASHRAE recommended guideline for inlet air temp, which is 81 degrees Fahrenheit. But I think if we use 75 as, say, a basis, that avails much more dramatic use of economizers based on the outdoor ambient conditions versus running your set points down in the 65, 68 Fahrenheit degree range. And then the last thing is containment. I'll talk a little bit about that. But hot and cold air containment is super important when you're using an economizer, because anything that we can do to actually drive up the return air temperature from the indoor cooling units really benefits the economizer and certainly the overall outside heat rejection and indoor cooling unit. We talk about ambient temperatures, ambient conditions. Here's another way to look at it from more of a global perspective. But if you look at this slide, really any of the geographies shown here that are blue or green represent a tremendous opportunity for the use of economizers. And we can be talking in the range of 4,000, 4,500, 5,000 hours per year and higher. And certainly as we push up into some of the northern climates like the Rockies, the Pacific Northwest, and virtually all of Canada, you have a tremendous potential for full or partial economization for every single hour of the year. If I look more specifically at the impact of the ASHRAE TC99 committee and the guidelines that they published, if you look at the green box on this slide, and this is a psychrometric chart for those of you that aren't mechanical engineers by degree or practice, basically what this does is it shows you that back in 2004, that narrow little green box was essentially the recommended guideline for temperature and humidity conditions for cooling units in a data center application. In 2008, and with a subsequent update to the standards in 2011, that range was expanded to the red box, which is shown on the psychrometric chart, and that's the recommended guideline. If you look at the blue box, that's actually the allowable guideline. So ASHRAE really delineates between the recommended and allowable, and it really depends on the tolerance for the data center owner, operator, or consulting engineer as to how far you really want to push the limit. But certainly by expanding these limitations and guidelines, it's helped us get more penetration for the use of economizers in the industry today. We talk about containment. What we're really fundamentally talking about is the use of any type of physical system that will separate the cold air, the supply air in the cold aisle, and the return or hot air in the hot aisle. So in this case, you can see examples of cold aisle and hot aisle containment. we're not going to talk, or I'm not going to talk in length about containment today, but what I can give you as a takeaway is if you're building a new data center, there's a lot of evidence and a lot of fundamental proof that hot aisle containment is the best overall architecture for a new build application or for use with a closely coupled cooling system like an in-row unit. If you're retrofitting an existing data center, particularly one with perimeter cooling units, cracks and crays, then cold aisle containment oftentimes is the best and most flexible choice for deployment in an existing data center. So would give that to you as sort of a nugget or a general guideline for the practical use of containment systems in the data center. But what we're trying to do here, in addition to making the cooling units more efficient, is to, again, drive up the delta T to the indoor cooling unit and also the return water temperature to the chiller plant, for instance, so that we can get more efficiency both inside and also outside. So when we look at the market overall for economizer solutions, there's just so many out there. It can become really daunting to figure out, which one's right for my data center. So let me talk and focus really on the top three. And I say the top three really from a performance benefit perspective. So the first one I'll mention is the use of using outside fresh air. And we see this very common on the West Coast in the United States and Canada. Essentially what this is a system of fans and louvers that take fresh air, outside air, from the ambient and actually brings it directly into the data center through some pretreatment and filtration. The louvers and dampers are used basically to control the exhaust of hot air, the release of hot air into the ambient environment, and also the supply air into the data center. One thing that's really important when you talk about using outside air is you have to make sure that you use appropriate pretreatment and filtration, because what we are doing is bringing in potential particulates and contaminants from the outdoor environment. And, it's a thing that has to be very, very tightly controlled. Things as simple as a airborne salt can actually cause corrosion on a printed circuit board and hardware failures. And it also has kind of a limitation in the sense that the variability of the humidity outside can also limit the number of hours that you can actually use outside fresh air, because if you're in summer months with very, very high humidities, oftentimes you have to resort to using a mechanical cooling system because the high humidity level in the outside air doesn't permit you to actually stay within the ASHRAE guidelines. So those are some of the pros and cons for using outside air. The next type I'll mention is something called a heat wheel. And a heat wheel is essentially a heat exchanger, typically very large in diameter. You can be talking about something in the range of about 12 feet, 8 to 12 feet in diameter. And what this is it's a heat exchanger that basically rotates and blows supply air through the heat exchanger to the cold aisle in the data center, and then separate fans blow the exhaust air from the hot aisle back across the same heat exchanger into the outside ambient. It's a really efficient type of solution. Some of the downsides are that because of the format and structure of the heat wheel, oftentimes the data center has to be purpose-built or purpose-designed for use. It can be extremely difficult to retrofit into an existing data center. And one mode that you can use with this solution to expand the number of hours would be an evaporative assist, which would just basically be a system that blows mist or water over the surface of the heat exchanger to take advantage of the evaporative cooling effect. The last one I'll mention is one that I'm a big proponent of, and this is the use of indirect evaporative cooling. And what this is actually a heat exchanger which provides full separation between the outside air and the treated air within the data center. And it really gives you two modes of economization. One is a dry air-to-air heat exchange, where basically the heat exchanger acts as a median between the hot return air coming out of the data center to the cold air, which is outside in the ambient. The other nice thing about these types of solutions is that you can use evaporative cooling to expand the window of opportunity for using the economizer component of the cooling infrastructure to a much wider bandwidth of available hours. So it's a neat solution because it allows you to really operate in these two modes of economization, and it also maintains complete separation between the indoor air and the outdoor air. And that's great because you don't have to worry about particulates and contaminants. So if I look at the overall performance of some of these various economizers I just mentioned, we look at the partial PUE, which is really the power consumed specific for the cooling units as a percentage of the total power consumed by the data center. And you can see that for the indirect evaporative heat exchange, you get a very low partial PUE of 1.09. And I used bin weather data for St. Louis to generate these numbers. So I'm not talking about the Yukon or some extreme ambient or geographical condition. I'm really talking about kind of the central area of the United States where you can gain a really low PUE, partial PUE, using these types of cooling solutions. You can see that the heat wheel also does quite well, as does outside air. And then, there's lots and lots of other types of ways to economize. I think certainly water-side economization is very prevalent for chiller plants, and also a pretty efficient way of achieving economization. But I think this snapshot gives you a pretty good idea of how the various technologies and products stack up from a efficiency perspective. So really, to conclude here, I think if you're in a part of the country, whether it be the United States or Canada, where the ambient allows or tolerates the use of economizers, certainly where regulatory requirements are already in place or coming, or whether you're just looking to make your data center more efficient as a whole, there are a lot of different ways to employ economizers to your facility to really drive down your use of power and hopefully lower your energy bill as well. So want to talk a little bit about high-performance cooling and where we're going in the industry right now. I think one of the biggest changes is the fact that IT loads are variable today. In the past, IT loads were essentially static, so we've seen a change in the way that we actually have to modulate or moderate our cooling systems based on the actual IT load. And we also see that in the past, airflow requirements were pretty much static or constant, and airflow requirements have really changed so that we have to be able to use proportional fan speeds for the delivery of cooling to the cold aisle. So when we talk about all these different changes, it means that you have to look more at the type of solution that you're using, and high-performance cooling might be an area that avails itself to help address some of these problems and challenges. Now, we've seen liquid cooling migrate into the industry, and I think everybody knows that IBM was using water cooling on mainframes back in the 50s and 60s. Well, we've seen that adapt to gaming systems and high-density servers, compute platforms, and various types of gaming consoles, PCs. That's here. That's been in place for many years. It's a proven technology. Certainly the benefit of providing cooling directly on the chip or on the DC to DC converters is a very efficient way to do that. Some of the challenges is really that it has to be implemented really at the OEM level. The PC or console supplier essentially has to install that prior to shipment. If you're doing that in your data center, it's a pretty difficult way, pretty disruptive way to improve the efficiency of your cooling units, and it really requires taking your servers apart, which not a lot of people want to do. So I think one of the biggest issues today for liquid cooling is that it's really kind of a niche application due to the fact that it's disruptive to your IT equipment, and a lot of these technologies really aren't market ready just yet. Some of the cooling technologies that I paraphrase as being new, and we mentioned already, include fresh air cooling. I think we'll continue to see fresh air cooling being very prominent in the western region. The one part of the industry that's just taking off right now is the use of indirect evaporative cooling. We talked about that when we mentioned various technologies in the economizer portion of the presentation. We're seeing a few data centers out there that are using thermal storage, basically cold water, chilled water tanks for load shedding and peak shaving type applications. And then we're seeing liquid cooling in some high performance applications within laboratories and government facilities, but not really that prevalent yet in the common data center, and certainly not in the cloud and colo environment yet. So my view on this is, where are we heading? Well, perimeter cooling has really evolved. If you look at the solutions today that are available for companies like Schneider Electric and others, they've really come up to snuff through the use of EC fans and other high efficiency components. So the cracks and crays out there today are not like the old ones that you're used to with belts and shafts and things like that. I think they've come a long way, and they're pretty efficient. In-row cooling units certainly have become very dominant in the industry since 2006 when they were introduced. They continue to evolve. We're seeing better products coming out in the in-row market that are even more efficient. Containment adoption is becoming widespread, and the benefits of containment are a no-brainer. If you're not using containment in your data center today, I strongly encourage you to consider deploying it. It's pretty efficient from a first cost perspective, and you get an immediate payback. So that's a nice one to look at. And then also modular data centers. Containerized systems are really becoming more accepted in the industry, and I think these four areas are the biggest areas of opportunity for cooling right now. So we talked a little bit about how do you make this how do you get some sense out of this for your own facility, and where do you start? Well, I thought one way to do that would be to look at our own portfolio at Schneider Electric, and really when you segment our own solutions at Schneider Electric, we've got it broken down by rack, row, and room. And there's a lot of products on this slide, so it's really challenging to say, well, where do I start? I mean, should I be going with a perimeter cooling unit? Should I be doing an indirect air economizer? Should I be going with an in-row cooling solution? How do I make some sense of this? Well, over the last 2 years, we undertook a very detailed financial comparison internally so that we could help segment our own product portfolio. And we looked at modeling various data center sizes, rack densities, IT densities, raised floor, no raised floor. We used actual costs for heat rejection systems, piping. We used a average cost of €1 per kilowatt for energy globally. And we used our own EcoStream CFD tool to really validate all the assumptions that we made in the design and implementation of these architectures. And what we found was that most customers, and talking to customers, were keying in on things like performance and form factor, financial analysis that includes first cost and TCO, and then also various facility constraints and qualitative requirements, and also regional tweaks. You know, we know that there's no standard boilerplate that we can use for any data center. So the takeaway that we had in crunching all these numbers was really a selection chart, and we segmented it into small data centers and medium to large data centers on the left-hand side, there on the y-axis. And we used both open systems and contained systems, and we really broke it down into first cost efficiency, 3-year TCO, and also space. And just as an example, if you're operating a small data center and efficiency and 3-year TCO is really your primary objective, we found that in-row cooling solutions were really the best starting point for a small data center with these types of goals in mind. Whereas in a large data center, if you were looking purely at efficiency and you're using containment, we found that a product like our indirect evaporative cooling unit, EcoBreeze, was a great solution. I think across the board, if you're driving almost solely for first cost, a traditional computer room air conditioning unit or CRAE is really maybe the best starting point for you, because those tend to be lower in cost and still provide a pretty good payback on efficiency based on all the upgrades that have been made using EC fans and electronic expansion valves and so forth. So this type of tool is really a starting point. It's not a mandate, it's not a Bible, but it's a way for you to kind of break down a complex product portfolio, whether it be ours or some other manufacturers, and really just use it as a way to get the dialogue going with Graybar to talk about how you might develop a solution for cooling in your own facility. So I really appreciate the time with the audience today. I know we're going to be going to some Q&A now, and I'd like to turn things over to Carl in a minute. But before I do that, just a final word. If you haven't been impacted by economizers yet, you will be. So investigate it, talk to us, and we'll be happy to inform you the best that we can and customize a solution for your facility. There's a lot of economizers to choose from. It's complex. It's dependent on a lot of factors. So use the experts at Graybar and Schneider Electric if you have questions. And then select the right solution for your own data center. Everything is generally custom to your own goals, objectives, and conditions. So we want to make sure that we can guide you in the right direction. And by all means, I think we're pretty well prepared to do that based on the numbers and the analysis that we've conducted over the last 2 to 3 years. We have a lot of resources available. Here are a couple of white papers over and above the download that was available when you registered, and this is going to be available for follow-up from Graybar. So I'll let Carl explain that. Again, I appreciate the time, and I'll just transition back over to you, Carl. Thank you very much.
Joe, we thank you very much for the time that you gave us today. It was an excellent presentation, and we thank you for sharing your expertise with our audience. We want to go to the questions and answers Q&A period now, and I wanted to remind everybody that if you'll scroll down to the bottom of your screen, you'll see a little red Q&A button. I believe it's red, and if you click on that, that'll open a dialog window where you can type in a question, and we'll respond to that. Before we get to the questions, I just wanted to remind everybody that the presentation will be archived. We will do that. I wanted to remind that those 50 people that logged on first will get an email for a cup of coffee. Again, we thank you for being the first 50 to come online with us today. I wanted to let you know that the 3 white papers that Joe mentioned, we'll get that information to you all on how you can access those additional resources that Joe spoke about. So we'll be communicating with you via email on those resources. So let's get going on the questions. And the first one came from Brian, Joe, and he was talking about why was the Southeast excluded from this requirement for economization. Now, I'm assuming that one of the reasons is there's just not enough cool days or cool hours that would allow significant contribution for the use of economizers, so using one may not be cost effective. Are there other reasons why the Southeast was excluded?
Well, you hit the nail on the head, and if you look specifically at ambient temperatures, we have a limited bandwidth to actually use free cooling or economizers in the southeast area. The other aspect of that region of the country is that it's also typically very humid. So when it comes to economizer solutions and you look at leveraging dry bulb and wet bulb conditions, areas that tend to be cool during certain hours of the day as well as dry certainly avail themselves to a larger number of hours for economizing during the course of the year.
Fran asked a question and indicated support for economizer concept, but indicated that getting a return air of 100 degrees as was suggested in that comparison chart, was something that seems like it's not achievable. Can you talk about that a little bit, about getting that delta, to get that return air up around 100 degrees? Is that what the slide indicated, or am I interpreting the question wrong?
Yeah, so I think Fran was talking about the slide that we showed the performance of various economizer approaches, and I think if I recall, the slide had a 105 degree return air temperature. So the drivers for that really are you're not going to get 100, 105 degree return air temperature unless you're using containment. So using hot aisle containment is a virtual mandate. If you want to drive up the number of hours, you can use an economizer.
and I had mentioned that in the presentation a couple of times. The other thing that really drives that delta T is the type of IT equipment that's being used. So I agree with Fran that if you're talking about legacy servers, 2U, 4U servers, you typically are not going to get as high of a delta T across the server as you might, let's say, with the newer blade chassis and blade servers that are being used in a lot of data centers today. The other thing would be your inlet air temperature. So, for instance, using simple math, if I'm using a high-performance server, I'm using a blade server that has a 25-degree delta T across the server, and I'm using 80-degree inlet air temp, that gets you to 105. So really it comes back down to moving those inlet air temp set points up to the ASHRAE recommended limit, which is 81 degrees Fahrenheit, and then also the type of IT equipment in your facility, getting that upgraded to more efficient servers, and then using hot aisle containment. And that's how you get to 105.
Charles wanted to know if the slides would be made available, and we'll put the slides that we showed you today will be in a PDF format, and we'll archive, put them up in the archive. So if you wanted to download that PDF with the slides on it, you can get it. I had a question while we're waiting to see if anybody else types some in. Remember, you can go to the QA window at the bottom of your screen and type your question in, and we'll respond to it. My question concerns the heat wheel. Sometimes we refer to that as the Kyoto wheel. Are there any actual practical examples in the U.S.? Has there been a Kyoto or heat wheel installed in the U.S.?
So my own G2, pardon the pun, is that I think there's about 40 installations worldwide. I believe there are around 15 in Canada and a handful in the U.S. So it's still, I would say, in the early adopter, part of the uptick, but certainly there are enough installations globally where we can consider it a viable solution.
Okay. Well, Joe, we thank you for the time that you've given us today. It's been great for you to be with us and talk to us a little bit about cooling trends that are occurring in the data center. We thank you very much for your time. I'm looking forward to seeing you at AFCOM later in the year so we can get together. Don't mind your pun about G2 Talk. We appreciate the plug very much. What we'll do is if anybody has asked a question and we have not responded to it yet, we will get back to you via email. We've collected all the questions in the database, and we'll be back to you. I wanted to remind everyone that the information here is archived on graybar.com. Just click on the G2 Talk webinar logo, and we'll get this information to you. Again, we'll also send you some information about the additional white papers. So you can expect an email from us giving you a method to get the additional white papers that Joe mentioned here. So we thank you very much for your time today. We appreciate you participating in the G2 Talk webinar series. Our next one will be coming up, I guess, next month, third Thursday of the month, and we're looking forward to your participation at that one as well. Have a great day, and enjoy your 2014. Everybody have a great day. Thank you very much. Goodbye.